Hello and welcome back, arcade and electronics enthusiasts. Here on the board, on the bench, I have yet another Carnival board set. And the one thing I know about this board set is this chip is good because I tried it in a previous Carnival repair, and I believe this works minus some sounds. This is completely untested. I don't know. As far as I know, this does not boot. That's what the note said with the board, is this doesn't boot. So, yeah. We've got the kit here. I think I will eliminate all of these ROMs and put the single 27128 in here like I did on the previous one, and have that as a backup to this instead of all of this, because this is very unreliable. All of these EPROMs are just, it's just not reliable. So what we'll do is we will go through, and I've had a lot of requests for showing how I clean boards. So I'm going to detail that in this repair. Look at how nasty this board is. I don't know if it's the camera's doing it much justice, but this board is filthy dirty. We'll do a reconditioning on this board. We'll resolder all of the headers. I'll replace a couple of the sockets just to do it. I'll replace this one, this one. We'll go ahead and replace these perhaps, and this socket, so that you can see how I clean the flux, clean the dirt, clean all of that in this repair. So that is the plan. And yeah, so first things first is we do need to, this board needs to be cleaned. So I'm going to strip this thing all the way down, get all of the chips off of it, everything, and we will I guess I will maybe just go ahead and remove some of the sockets. Let's do that. I'll go ahead really quick, remove the sockets that we're going to replace, and then we'll wash this. We'll take it in and clean it up. Alright, yeah, this board is really bad. It's got bad sockets. These sockets right here are junk. These ones look a little corroded and nasty, as well as all of these. So, yeah. So I'm going to replace, those three need to be replaced. I'm basically going to replace every socket on here, except for these. I will replace this one, because this is where I'll put my one chip. You know, you want to have a backup. You have to have program in this thing if this thing quits, because I don't care for these high score save kits. They seem to be flaky. It might be working now, but a year from now it may quit working, and you want backup on this thing. So we're going to put a one ROM solution on this thing. Replace this socket only, and then replace all of the other ones. And these, all of these headers are really bad. Lots of cracked joints. Yeah. Power input header, let's check it out. This is the power input. Yeah, it's hanging on by a thread. It's not terrible. It's not the worst. There's a crack joint. Yeah. And the video input. cracked. 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 Yeah. Okay, so these will all have to be resoldered. We'll have our sockets in here, so we'll have a lot of flux on the board, and we'll go through cleaning all of that off so that it looks like there was no work done to the thing. So we'll clean it. We'll do all that flux work and all that, and yeah, it'll be good to go. First thing I'm going to do is get my desoldering gun out, and I'm going to remove sockets. Then we'll go into the house and clean this board. Okay, actually going to do this outside in this big tub that I have. I got the board in there. I've removed every socket that I'm going to remove. So this is how I wash these boards. Take mean green and just spray it good. And I do front and back. You can already see the filth coming off. And I take a nice big brush and just kind of go over it. Kind of carefully, you know, lightly. Careful with this pot, just kind of, you don't want to be going like that on that pot, just kind of easy. Kind of get on the other side of these things. Give the back a scrub. Okay, now we can rinse it off. And you'll see all the filth water. Dirt. Look at all that dirt in there. Rinse it really good. Okay. I'll come around here and turn the water off. I don't know if this camera is picking this up, but Look at that dirt. All that dirt down in that end. It's kind of running down that way. All that dirt off that board. Yeah. All right, and now the next step. Be right back. All right, next thing you do is you take your 91% alcohol and just give it a good spray down. Get in all the nooks and crannies if you can. Front and back. Just spray it down really good. And then let that dry. And that is the last step. Just let that all run out and dry. So once it's all dry, we'll be back. All right, and I did use a air compressor to kind of speed up the drying process. Blew it off. And yeah, it's looking good. Clean. I mean, you can see a shine to it, right? Reflection. Yeah, all of these sockets removed. Basically all of the sockets removed. That one, that one up here, this one where I'm going to put the single ROM, these three guys, that one. Yeah. I removed all the tantalum capacitors as well, as I don't want them exploding as soon as I turn it on. I'll replace the caps. And yeah, so we'll have to do the soldering. We'll have to put the sockets in, solder in all the sockets, resolder all of the connectors, and then we'll have a mess of flux on the board that we'll have to clean again. And I'll go over how I clean flux off the board. So it's kind of a two-step process. And it will look like this board has never been worked on. It'll look factory fresh. So, yeah. Alrighty. So next thing to do is repopulate. Let me get to it. Okay, and all of the sockets are soldered in. And I resoldered all of the connectors. No more cracked joints. But there's a lot of flux on the board, so we will now wash the flux off. And that is a process of, well, I need to put these caps in. Let me do these capacitors. And yeah, then we'll do it all at once. But it's a spraying it down with alcohol and scrubbing it, and then you have to rinse it and spray rinse it with alcohol and wash all of the flux off of the board. Otherwise it will dry, the alcohol will evaporate and the flux will still be stuck on the board. So it has to be spray rinsed off, and I'll show you that. Okay, and the caps are in. It's just a handful of 10 microfarads, and this is supposed to be a 100 that filters the 5 volts. But the 100s I have are super tall, so I put a 220 in there, which is absolutely fine. So now we can spray and scrub this up and then take it out and rinse it. Okay. And I use 91% alcohol and just give it a good dousing all over. Anywhere that you know there's flux. Alright. And then I just take my little scrub brush and scrub over it. Get it really good. Really loosen that up good. And give it just, spray it again. Keep it good, and you don't want it evaporating out. You don't want it drying right now. Really loosen that up and get that flux off of here. Really loosen it up good. Okay. And then that's good. And then we'll move on to the next step, which is rinsing it. Okay, and while this is still wet, you do not want this to dry yet. You're going to take it. Let me come around the other side. Take it and just spray it down really good and wash all of that flux off of the board. And when you have a lot, you'll see it. It's like brown when it drips off the bottom of the board. But this flux that I use is pretty clean, so it doesn't really come off brown. But you really want to spray it good so that it really runs off. Really wash that off. And that's going to do it. Now it's just letting it dry. Sometimes when it's sunny out like it is now, I'll let it dry out in the sun. Sometimes I'll just use the air compressor and blow it dry. Doesn't matter. But that's it. So we'll let this dry off and I'll be back. Okay, and as you can see, I've left it to dry out in the sun. It's a nice sunny day. Let's take this thing into the shop and check it out. Alright, and here we are. How's it looking? Put the glasses on. Yeah. No flux. Nice and clean. There's all these RAM sockets. Just shiny clean. And we have some more headers. No more cracked joints. And no flux left all over the board. And just sparkly clean. One socket replaced there for the single ROM. Yeah. All new caps up here. Got rid of the exploding tantalums. And we are ready to start doing some troubleshooting. I think the first thing I'm going to do is grab the Inquisitor and test all of those RAMs and see if the RAMs are all good, or do I need to replace any of the RAM. And then just repopulate. Yeah. I think the first thing I'm going to do is program my 27128 and get it all wired up, because I want to run this thing on the regular program instead of that high score, because once you put the high score save kit in this thing, it kind of ruins the socket. So I would rather do it with just the Z80 first and run it on the program, and then go from there. Yeah. Beautiful. I actually have these sockets laying around, and they're old junky sockets, but they kind of work good for these things that plug into stuff. They have kind of longer leads, so you can put them in a socket and then put your kit on top of it. So I think I will do that. I'll do this with the kit to start. This way I save my socket that I put in. It won't ruin my socket. I can plug the kit into that. That's what I'll do. Okay, so I tested all of the RAM and they were all good. So I repopulated it. Got everything in. Got this thing put into that little socket that I put in my socket, which is nice. And it's on, and there it is. Video looks perfect. So we'll go ahead and hook up the soundboard, hook up my controls, and see what we get with the sound. Alright, before I do hook this up, this thing has some cracked solder joints. Yeah, so I'll go through and resolder these and clean the board on both boards. I'll have to do this header too. So let me go ahead and do that before I even plug this in. Okay, I have found that this thing is missing a couple of sounds, and I should have done this on my first Carnival repair. I don't know why I didn't. Just get a little wire and ground it, and then you can, off of the schematic, bear is P13, so you can just ground P13 and you'll hear the bear sound. Hear that? P11. Yeah. Duck 3 is P110. Duck 2 is P17. Duck 1 is P16. Missing. Pipe hit and rifle shot are missing. 2, 3, 4, 5. So once again, it looks like we got one of those chips is bad. This is interesting, which I did not see on my other Carnival repairs. This has a resistor jumped across right there. Some kind of an upgrade. And if I turn this thing over, I'm looking at the schematic over here. Ranking P12. Nothing. I don't know. I guess that's, I don't know what that's supposed to sound like. P2 number 8 is bonus number 1. P2 number 8. Okay. Clang we already heard. Bonus number 2 is P14. Yeah, so we're missing a few sounds. We're missing this ranking. And we're missing a duck sound. We're missing duck number 1. And the pipe hit and rifle shot. So this one will be probably U1. I'll replace U1, and that'll probably be duck number 1. Yeah, you can see U1. Yep. And I'll have to replace that MM5837 for the rifle shot and stuff. And this ranking, probably replace U13, possibly the op amp, U9. U9 is used over in the Bear circuit, so it's probably not U9. It's probably this U13. Who knows? Yeah. All right. Well, we'll get to it. Just start replacing some stuff, actually. See what happens. Okay, so what I did was I removed this guy, which is U13, this one right here, and this one also has a couple up here in the clang section. So I removed U13 and it tested good. So I took U13 and moved it to U1. I removed U1. This is U1. So this chip used to be right here. This one tested good, so I put it in there, and now I have all 3 of the duck sounds. This is number 1 right here. 2, 3. So I have all of that. My clang still works. Cool. So that chip's good in there. This I still don't have nothing going on with U1 pin 2, which is P1, pin 2 ranking. So maybe I can try jumping U9 and see if anything happens. And I have a socket here for this guy. That's this noise generator right here for the pipe hit and rifle shot. I will put the chip in there. But as for now, this is U9 right here. It's an op amp. So I'm going to try jumping over that and then see if I get anything for this ranking. So let me do that. I'll be back. Okay, I jumped a chip over that amp. And now when I hit that, I get a pop. Hear that? So, let me... Yeah, it's not too excessively hot. Yeah, let me replace this amp because I think that might be a bad amp. Only part of it's bad though, because some of it works with other stuff that does work. So let me go ahead and replace this guy. Alright, I was just replacing that, and I came across this. It's kind of interesting. It is broke off of there. I don't know if that has any, I don't know if that has anything to do with anything, but I'm going to go ahead and solder that lead to where it looks like it goes and see what happens. Put a chip in there and see what happens. Okay, yeah, I swapped and replaced this TLO84 with a new one, and it just did the same thing. It doesn't do anything on that. So anyway, I don't know what this ranking is all about. It doesn't seem to do anything, which is, I don't know. I've replaced U13. I mean, transistors. I got transistors. There's this FET in here. We have a capacitor right here, 0.05 microfarad. This tantalum, I checked the tantalum, it's not shorted. There's some caps in here. I don't know. I'll do some checks with my meter on the transistors and stuff like that, but other than that, I don't know what this is even supposed to do, so yeah, I don't know. Anyway, we got clang, bear, that. All of the duck sounds. I still got to get this chip right here. We got bear. Yeah. Isn't there another bonus? Clang bonus 2, bonus 1. P2 8. P2 number 8. Yeah. But we're good. It's looking good. So let's go ahead and I don't know. I might just send this back like this. Send the EPROMs back separate. And he can put the EPROMs in there if he pleases. Just send it back the way it is. I might just do that. Anyway, yeah. Well, let's play a game of this and call it good. Wrap it up. Okay, it's time for gameplay. Now I am going to come back and demonstrate the pipe hit and the rifle shot once I get that chip. I only bought one for the prior repair, but I bought one from a US seller. And I bought one from a US seller, and I bought like 10 of them or something like that from China. So I got to wait for my China order. And yeah, so anyway, let's do this. Carnival's a fun game. Dang it! Damn it! Such a fun game. And like I said, well, let me turn the lights on. We're calling this one good. I'm just going to send the EPROMs back in a tube. I'm going to put them in a tube. And I marked them on the bottom of the ROMs themselves. I put the location. That's number 8. I'm going to put those in a tube and send them back that way. Yes, I don't think I have another 27128, to be honest with you. I think I had 2 of them when I did the last one, and one of them didn't work. One of the ROMs was no good. So it's cleaned up. I replaced one of the sockets. It's cleaned up anyway. So if this thing ever fails, which hopefully it doesn't fail. And I did put it in a socket and then put that in the new socket, so it will not ruin the socket that I put in the board for just putting the Z80 in. So you could put the Z80 in the board and then put your 2708s in, and in theory be good to go. So yeah. Excellent. All right, well, I'm going to stop this one for now. I'm waiting on this chip, you know, that noise generator. And all that does is the rifle and the pipe hit. That's it. So when that gets back, I'll finish this video off. But yeah, this one, man, look at how nice. Nice new sockets everywhere. It's beautiful. Okay. I'll see you back when I get my Chinese order. All right, I was out here looking at this because I have got to figure out what is the deal with this ranking sound, right? Well, I followed this signal all the way to the amp. And I just got to the conclusion that the amp has to be not working. It's something about the characteristics inside the amp. Okay. There are a few different types, a few different numbers, if you will. This is U9 says all op amps are LM348. Okay. LM348. Well, that crosses to a LM324. It crosses to a TLO84. And so I tried a TLO84. I don't know if it crosses to an LM324, to be honest with you, but it probably does. But LM324 is like a general purpose, lower characteristic amp. This one has to obviously handle, it's just a different, maybe it's a higher impedance input or what, you know, I don't know. Current characteristics, something's different about what is needed here. This is a very finicky board with the 4069s and with the amps. What I have found works is LF347. Those are pin compatible again, and I grabbed one of those LF347s and put in the board. That's actually a Russian version, I think. But now that's it. Now I have all the sounds. Except for the shooting, you know, the rifle and stuff, and that's just the one chip. But LF347 seems to be a good replacement for the amps on this board. And I would say for these chips, the 4069s, I would try to get like a 74C04, not HC, not HCT, just a regular 74C04 or a CD4069, and just try them until they work. This is the is this it? Nope. So where is that chip? I don't know. Yeah. I think this is it, maybe? I don't know. But let me put this up here and give you a view of the scope really quick. And I will show you the little FET. If I can find it again. That's got to be it, right? This is the input. Yeah. And this is the output, and when you do the sound it should do that. Yeah, see that? That's the signal through the FET. And I'll show you that FET. It's right here. So I was probing, that was the input right there. And then what I was probing where it was doing that was, you'd see it going up and down. That's this pin right here, which goes to the positive of the amp. And all this is a feedback loop. So when this goes up, this feedback's going to drive this high. It's going to, the feedback's going to, how an op amp works, it's going to try to equal out the inputs. So it's going to drive this to equal this. So I just got to the thinking, I was like, the amp has to be bad. It's the only thing. It's not that it's bad. It's just not compatible. So yeah, LF347 seems to work as an amp replacement in this board. So keep that in mind. Yeah, so this should, yeah, see? Boom. Coin. There. Man, I'm so glad I figured that out. Alright, that was really it. Now, just gotta wait for that one part. Okay. After speaking to this customer, they wanted to just forego all of the 2708s and have a good solution here, which I had the new socket for, so I made a new solution. Now, instead of using a 27128 here, I used a 28C256. So I just doubled up my file, and it's almost exactly the same as the first time I did this with the 128. The only difference is this is an electronically erasable part, electronically rewritable, I should say. So you do have to do an extra step if you're going to use this style of chip. And what that extra step is both the output enable and chip enable you want to pull and combine, as you can see I have here. You see how I have them pulled up and then bridged over together? Now before I had the output enable just in the socket and it can be grounded. And then I ran the chip enable, I ran just over to ground right there. You don't want to do that with an electronically erasable part because it can rewrite itself. See, and I've experienced this. I've had this happen to me before when I was messing around with these 28C chips. What happens is these have a write pin, which is right low, and it's the second pin up here. It's tied to 5 volts, yes. But if you have both the chip enable and output enable grounded from the get-go, as soon as you power this thing on, this thing's enabled. So it could take just nanoseconds, milliseconds, whatever, for this power, when this power rail is coming up, depending on how this chip is looking at that, it could, if there's junk on the data, just random junk on the data lines, it can write that data into this chip. So the solution to that is you need some kind of a delay on the chip enable and output enable so that this thing stays high until the power rails are stable. And how I did that was, you can see I've got the line here connected to both output enable and chip enable, and it comes over here to this 04, and then that in turn is connected to that 04 now. This is the reset timer. Okay, when this thing goes into, when reset clears, pin 3 of the 555 goes low. So here I have, and on the back of the board I just soldered the output to the reset. I soldered it to the next pin because it was floating. There was no connection to it. So we have low going high, and then high again going low, and I'm sending that low over to non-used gates on this thing. So we have a low going high here, and then a high going low here. And that low comes over and activates this low. So you have 100 nanosecond delay-ish on those signals going low. So that power rails have time to stable, everything can stable, and then the thing will enable. And hopefully that makes sense. But yeah, if you're using an electrically rewritable chip, you have to have a delay on the chip enable. Chip enable and output enable can be tied together. It doesn't matter. But there has to be a delay there so that the thing can stabilize, so that it doesn't rewrite itself. So that is the extra step. You have to just make a little bit of a, a propagation delay over to here. Yeah. And it works fine. Yeah. So that'll always be here. If the kit fails, I can put the kit back in it now. So now I'm going to go ahead and do that. But I just wanted to get this squared away. That'll always be a good backup. And once again, I didn't cut any traces on this board whatsoever. I just kind of soldered around, that's all. So let me put the kit back in it and go from there. Okay, and yep, with the kit back in it, it's back the way it was. Running, and there's the high scores I put up there. Yeah, so yeah, this thing will always be here if need be. Nice backup. That's it. Now I just wait for that one part for the pipe hit and rifle shot, and this thing will be good to go.